The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.
Krusty?
Yeah, I heard my name just then, boss. What do you need?
Since you're new to this outfit, I figured I'd tell you my backstory.
Oh, that would be an honor, boss.
I wasn't always like this, you know? I used to work in a bakery, making pies. Then one day there was an earthquake, and I fell into a vat of radioactive pie filling left over from Chernobyl. My DNA fused with the pie filling, changing into PNA, making me half man, half pie. From that day on, I became known as Pie Face.
Is that why we're building the Pytomic rocket?
Indeed. It's almost ready. We only need one more ingredient. And then we'll launch it into the atmosphere. It will spread a radioactive pie filling all over the world, changing everyone into half pie, half human creatures like me. The world will have their just desserts.
Amazing hacks.
How can we make this portable?
Inspired designs.
I am the internet troll.
Regrettable acting.
Batten down the hatches!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
The purpose of this project is to create some spy equipment. I was thinking, what kind of cool things could a private investigator use to do their job? They're often filming people either cheating on their spouses or insurance fraud. So what would be useful? We take a lunch pail and we put a telephoto lens here, and then we make a mechanical zoom control for it. We have a USB camera that goes to a Raspberry Pi, and there's a battery powering everything. There are controls here for start, stop, record, and zoom in, zoom out. So again, you're doing it very inconspicuously. And then the video feed, what's happening, goes up to a miniature LCD inside your glasses. So you can be looking wherever you want, but as long as you're pointing the cooler where you want it to be, you can get a shot. So I thought that'd be a really sneaky way, to get the dirt. Let's get started. So these are the My View personal video goggles. One of the projects we saw at Maker Faire was using one of these. It looks like this black piece, which does absolutely nothing, snaps over the inner frame, which is what actually comes apart. Actually, this looks more like RoboCop's visor than Geordie LaForge. And if you don't know who Geordie LaForge is, then, well, I don't even know why you're watching my channel. Okay, it looks like whatever's in here is mirrored on both sides. So there's an optic here, and then this is probably the LCD. This is the main cable going in. So this connection is just for the earbud. Ooh, there's a lot of connections going into this. That's kind of scary. Looks like there's an input here, another ribbon cable, and then there's probably gonna be a ribbon cable going across it as well. So it's a good thing I didn't follow the instructions I found online, which are like, cut it down the middle. Oh man, that's behind, those solder points are behind a ribbon cable. Well, I'm just gonna cut it because we don't want the earpieces anyway. They're not very good. Oh, there's a ribbon cable. This Captain tape is just apparently holding the ribbon cable in place. So what it does here is the image is in here, and then you see a reflection of it through this lens. So you're kind of looking sideways. So it bounces over and then into my eye. So I guess one of the questions is, can we get by just using one of these? Actually, before I get too much further with this, I'm going to crack open this control just to see if there's anything in it. There are a couple chips on here. I wonder what they are. There might be some on the back too, so. Oh man, this thing really loves its security screws. Yeah, I wonder where these get their power from. I wasn't aware you could source power from an iPad port. I mean, I'm sure it's there, but I think it would drain the battery quickly. Oh, okay. There is more on the back of it. So when you send commands to the iPod, such as volume up, volume down, it sends them as a serial command using RxTX, old school stuff, at least on the old style ones. There's quite a few things on this connector actually. So I'm sure it's doing that at least. And this could very well be an encoder chip for the video. So we may need to keep this dongle as part of the unit. And then it's been soldered and covered with hot glue, of course, because it's cheap. The old school iPod port had quite a few things on it. USB, FireWire, composite video, and RxTX for communication. So if you had a device like an external controller, it would actually send RxTX, basically RS-232 signals at 3.3 volt logic level to the iPad. And that's how it would tell it to, increase volume, decrease volume, and whatnot. I have the oscilloscope hooked up to the transmit pin of the LCD dongle, and if we do a trigger on the scope, okay, there we go. So that's a data packet being sent from this to the iPad, and that's basically how the volume control or anything else works. So when you hit like next track or previous track, there aren't dedicated pins for that on the connector. Your device needs an RxTX, RS-232 type serial communication to tell the iPod or iPad what to do. Of course, that's all changed now. They have that double-sided connector, but in the old days, that's how it worked. There's actually labels on this connector here. I see ground, power, RxTX, that's how I knew where to hook this up. Video, video ground, audio, AV ground, iPod detect. Yeah, so it looks like these are all well labeled. So what I think I'm gonna try next is actually hooking just an NTSC signal up to this using my old Nintendo. Shadow of the Ninja, great game. When I was a kid, I rented this like 3 times from the store, and then I'm like, I should just buy it. So I bought it. Okay, I have the Nintendo running on the eyepiece. It's kind of, it doesn't really look like a big screen TV floating in space. It looks like kind of a small little screen off in the distance. So I don't think the Oculus Rift has anything to worry about. I just need one of these eyepieces. I'm gonna try to get it to work without this cable. So without this crossover cable, it doesn't turn on. That's odd. You'd think it would just be like a duplication of the signals, unless it's sending signals over and then bringing them back. But that doesn't make any sense, unless it does. So this LED isn't on, but maybe everything else is working. So I'm gonna power that. Oh yeah, it is, the image is working, but the LED just isn't when you have the cable disconnected. Weird. Yep, if I shine this LED flashlight where the LED was, it illuminates the image. This flashlight's actually way too bright, but okay, that's good. I'm wondering why that is. I mean, the most obvious explanation would be that these LEDs are powered in series. So it powers one, and it powers the other one, then it returns over to that one again, which means if this is disconnected, this circuit can't be completed. That also means if I'm only running one LED, I would be running it at twice the voltage that it should be at. So I might need to add a resistor in there to make up for it. But it does show that, yes, we can run this without this side. So what I should probably do is just hack this up with my Dremel right now. I think the easiest thing to do here would be to figure out where the circuit is being broken on the LED and then just rig it so that the single LED will light up. It's probably the best way to do it because, it's already, that's what it's intended to do. See, it fits right on. Easier to use what's already there. So I tested the pinout of this ribbon cable and I realized the LEDs were in series. So what I did was I made up for this loop here going to the LED by just attaching this LED through a resistor to ground. And the resistor makes up for the fact that one of the LEDs is missing. Otherwise, it would overdrive a single LED. But yeah, it looks like everything's working. Let me turn this on, turn this on. Yeah, I used Captain Tape to wrap everything up. I wrapped the ribbon cable connection and the PCB as well. So what I'm thinking is this could either go under the brim of a cap like this, right? Or you could probably even fit it behind sunglasses. So you're like, hi, I'm just wearing sunglasses. I'm not a spy, so just ignore me. It still needs this board here because this has the drivers on it. What I'm thinking we can do is put a plug here. So when you plug in the Raspberry Pi, it provides power, ground, and video signal to this, and this will feed the eyepiece.
It's time for a tech timeout.
In this build, we use the Raspberry Pi, and in order to get everything set up on the Raspberry Pi to do the video capture and display the video in the spy glasses, we're not gonna really have much of a display to interact with. So I set up the VNC service, which is Virtual Network Computing. And what that does is port over the graphical desktop environment over the network to my main system where I'm doing all the editing with, or the interacting with it. So first thing we need to do is SSH into the Raspberry Pi. Now that we're logged into the Raspberry Pi, we'll initiate the instructions to start the X server and the VNC service. So what we do is X init --:1 for display 1 and that, throw the process into the background. Then we'll do X11 VNC for starting the service, connect it to display, DISPLAY, display 1. There's also some other flags that we can use to start the service. There's some security authorization files that we could add to it, but we're just doing this for demonstration purposes. If you want to, you could check the man pages of X11 VNC. And then starts the server, starts the service. And now to connect to the VNC server, we'll do VNC viewer. There are a number of different VNC clients and servers. These are the ones we're using, X11, VNC, and VNC viewer. And then we'll put in the Raspberry Pi's IP address, 192.168.1.130. There we go. And now we're able to see the desktop of the Raspberry Pi through the VNC service.
Well, Felix, I completed this part of the project. Sliced apart the My View crystal thing, put it into these glasses, and then attached a 3.5 millimeter jack on here so we can give it video, power, and ground from the Pi.
Great, because I just finished the jack for your plug.
All right, let's test them out together. All right, Felix has activated the camera, which is right here. And I am looking at myself with these glasses. Okay, so this looks a little blown out because of my cell phone camera, but this is the view inside the glasses of what the camera is seeing. Basically, we've ported the Raspberry Pi screen out to this little display that we've embedded in these sunglasses. Do you want to try them, Felix?
Yeah.
Look, I'm going to steal all Felix's tools. He'll never know. Ha ha ha.
Oh, I know that you're stealing my tools.
Oh my God, how did you know I was stealing your tools?
Because I'm watching you.
Are you a spy or something?
Yes, I'm the evil villain.
Oh, that's right, I forgot.
And I know your plan.
Okay, we have the glasses working with the Raspberry Pi. The next step is to adapt it to work with this zoom lens. So you're sitting there and you can zoom in and see what your target is doing in the car across the street, just like a real spy. So this will be embedded in the lunch pail, and we'll need a way to mechanically actuate this in order to do the zoom action. So what I'm thinking is there could be some buttons on the handle, just like a professional camera might have, and those buttons could tell the Pi to drive a servo or something to actually move the zoom lens. What do you think's inside this cooler? Do you think air or foam?
Wait a minute, did you just push it in?
I've been trying to. It's pretty sturdy. Because usually they use
Let
a
me look at-
vacuum, you know, to make things cold or hot or not change heat, I should say.
You know what? I'm starting to think it's empty.
You think it's empty? Okay, so is it empty, but is there a vacuum? That's the next question. Because this is like a $10 cooler. This is like literally the cheapest cooler I could find.
I think if there is a vacuum in there, it's there just because it happened.
But wait a minute. If there's a vacuum, it would cause the plastic to collapse. So unless this plastic is super thick, which it isn't, there couldn't be a vacuum unless there's foam spacing. But again, I think we're really overthinking it for a $10 cooler. No vacuum. You know, the same thing happened to Geraldo, and his career never recovered. Now we can see exactly what was in it. That's interesting. I smell something. Maybe there's some kind of gas in it. Well, obviously there's some kind of gas in it, but. Oh, wait. Is that foam? Oh, we need a screwdriver, Felix. Oh, look!
I knew it was foam.
Foam! Wait, before you didn't
Yeah, I
think it
know.
had foam.
I said the first thing I said was foam.
So you were right.
But then I.
This is the USB camera that we intend to use. We're going to attach it to the lens. To do so, we take several measurements of the inside and outside diameters, including the threads, and then we draw it up on paper to make sure we have it all before we design a 3D printable part. Okay, Felix, we've got the 3D printed part done. We made a lens adapter, and there's also a spacer that goes on the USB. So that should screw in place, right? Mm-hmm. Now, we didn't actually print threads. We just printed it at just the right size so the metal threads on the camera lens would bite into the plastic. So it actually took us a couple tries, like 3 tries to get it?
Yeah.
Well, that's 3D printing life. So Felix, why don't you tell us about that camera module a little bit while I try to screw this together?
So this is the MBest 8200U camera module, USB camera module. It has 5 megapixels.
That's many megapixels.
5 whole megapixels.
Okay, so now we're going to mate it with this, and then the USB is up, right?
Yes.
Okay. Okay, can we do a test of this?
Yeah, let's do that.
Yeah, this actually feels like it belongs. So the camera module itself down here has a mechanical focus. So we're just using the zoom ring on the main lens to zoom in on whoever you're spying on. Now find piefish. That's the last thing I do. We have the zoom function working. Cool. Okay, I 3D printed a bunch of parts for the lens mount. Here's how I made them. All right, so Felix had the idea to use a parametric pulley to actually drive the zoom lens. So I opened up a pulley here in SCAD, which is kind of like a programming language 3D modeler, if that makes sense. Okay, so I'm gonna bump up the number of teeth to many, just to make sure. And the shaft, or the hole in the center, I'm gonna make that 53.5, which is the outer diameter of the zoom lever. Okay, let's render that, okay. So obviously we don't need that many teeth. So the idea is we can slip this over the zoom ring and then put a tooth belt on it. And we gotta find the pulley height. Okay, let's go with 12. Oh, wait, no, 11, sorry. I kind of like this retaining clip here. That could be handy. Let's see if we can get one on the other side as well. Oh, here you go, belt retainer over teeth. Okay, we need to just put one there and it should pop up. Cool. Yeah, and if it's not quite tight enough, we can actually make a slit with the bandsaw and then just squeeze it around the ring a little bit. Again, it's often easier to hack something than it is to draw it perfectly, especially when you're in a crunch. Okay, we will print this after the current print finishes. Too much printing. Okay, I'm going to make the second pulley now that will actually attach to the servo. All right, so the motor shaft on this one, I'm going to make, pretty small. Only thing we really need it for is a center point for reference. I'll make it match a feature on this pulley here. Let's say about 6 millimeters. All right, so if the zoom lens needs to rotate about 100 degrees, that means, the servo would have to move 100 degrees if it's a 1-to-1 ratio of the gear sizes. However, I don't think I want 2 gears this big in the system, so I think I'll make this gear smaller. So I'm going to reduce the number of teeth from 40 to 30. Re-render. All right. Yeah, so the servo will probably have to go its full extremity, probably like 0 to 180 degrees. Well, I guess we can figure that out. 180 degrees times 0.75 effective range because of the gear ratio. 135 degrees, that still gives us plenty of overhead for what we actually need to move the zoom lens. So I'm going to print this as well, and then I'll just manually attach it with screws to a servo, and then we'll use a servo to drive the belt.
Okay, so this is the ring that I did in OpenSCAD for the focus control. And I made it a little bigger than it needed to be, but that's okay. I'm gonna actually put some tape around the knurling so that it has not a super tight fit, but at least doesn't move around and stuff. And I'm gonna use this fake gaffer tape that we have because it shouldn't leave residue. So what is the difference between painter's tape and masking tape? Well, painter's tape won't leave residue. That's why it's good for painting. After you're done painting, you can remove it and have a clean, glue-free surface. There's also something called gaffer's tape, which they use in video production. It looks like duct tape, but it's usually black. And it's basically duct tape that doesn't leave residue, but it leaves a hole in your wallet because it's expensive. All right, let's slip this in. Okay. I'm sure I'll get a call from Langley any minute now wanting to buy this. I'll tell them it's like $300 million, and I'll be like, oh, okay, all right. We can use this to find the existence of aliens, finally, Scully. Hey, like doing Scully and Mulder impressions will be relevant again soon. Sometimes when you connect 2 belts together, you can just use a clamp or a special 3D printed piece. However, these 2 pulleys are too close together for that, which means there's really no part of the belt that won't go through the teeth. So I've actually glued a piece of belt onto the back of the belt in order to make a contiguous belt of a specific length. I have the belt in place, so the servo will actuate it and manually move the zoom. So far in this episode, we took a MyView personal media viewer, hacked it up, and built one of the LCD units into these normal sunglasses. We then hacked up this cooler by cutting a big hole into it, mounting a zoom lens, putting a USB camera onto the zoom lens, and making a servo actuator that can zoom mechanically in and out. In a future episode, we're going to finish up this project by installing the Raspberry Pi, servo controller, and a battery pack, as well as putting controls up here for operating the camera. So we'll take care of that in a future episode. But for now, let's get back to the spy action.
Monosodium glutamate. Kids love it.
And sugar. This rocket's gonna be sweet.
Yes, only one more ingredient. The rocket will be ready.
And that's as far as you'll get, Pie Face. I'm here to stop your steamy, schemy shenanigans.
Bondendorf, my arch nemesis.
I've had my fill of you, Pie Face. I'm going to stop your half-baked plan.
Crusty, make him wish he'd never smelt a pie cooling on a windowsill.
Prepare to get creamed.
Mr. Bondendorf, I'm afraid this is your final slice.
Tastes like my goose is cooked.
Come with me if you want to mod.
Huh?
Geordie LaForge is super cool, but you don't have to take my word for it. Game over, McFly. Used to say, live and let cake. That is so dumb. My fan fiction Roadhouse remake. So last week, Max for some reason says, game over, McFly. And I'm like, that was never said in Back to the Future. That is not a line from Back to the Future.
Now it's time for the dick timeout.
I'm going to stop your steamy, scheming shenanigans.
Well, I guess it's your operation, Pie Face. I mean,
They
like...
call me Mr. Pie.
Okay, you told me.
I'm going to stop your steamy, scheming shenanigans.
I heard my name, boss. What do you need? Thanks.
Thanks for acknowledging my existence, boss.
Your steaming, your steamy, scheming shenanigans. The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.